the promise and the really cool thing about the model context protocol, which I would like to introduce next, is that it's supposed to be something that allows you to simplify all of this by saying, no, 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 write only the connection to MCP, and MCP will hook it up to resources, tools, and prompts. And I'm simplifying now, but we're going to make that much more clear in just a bit. But the idea is MCP is going to allow you to only concern yourself with making sure that your application hooks it up to MCP, and MCP is going to set up the connections to resources, tools, and prompts, simplifying the problem that we've just described to a m+n number of potential integrations. Now, that begs the question, what is MCP? Now, let's start very friendly, very simple, very easy. It's an open protocol to standardize connections between LLMs and context, whatever context looks like in this scenario, right? So we're not talking about resources, prompts, or tools, or sampling. We're not talking about anything specific. We're saying something that hooks up LLM to context. Context can be a tool the LLM needs to perform a task. Context can be a database. It can be a PDF file. It can be whatever it needs. So the idea is let's standardize the way that we hook up LLMs to context. Now, in a very superficial sense, MCP is what has the potential to make AI super useful for building real apps. And lucky for us, folks, after watching Anche amazing presentation on agents, it's super useful for building agents as well. So let's think about how MCP comes into play, what it is it facilitating, and a few notes on why MCP is so cool. So we had the point, MCP simplifies this integration problem for agentic development, right? Now, how does it do that? Well, what are the core components of the model context protocol? Now, let's start with the host. We have three major components, but let's talk at a higher level in a very simple way. What is MCP in terms of building agents? Let's walk it through it. So you start with the host, which is the user-facing application, something like Claude Desktop, Cursor, it can be ChatGPT, it can be whatever AI application that will interact with the user, that will interface with the user. Then within the host, we have these subcomponents that we're going to call clients. And the only task that the clients are going to concern themselves with is these one-to-one interactions with a server or the MCP servers. Now, the only goal and the only task the MCP server is going to have is to expose functionality that can be called or can be used by a client. And what is that functionality? You guessed it, tools, resources, prompts. So if I can just do a quick drawback to my slide number, I think it was slide number 2, just to give some context, folks. So we were in this situation where we had to write all of this code, right? We've talked about this in slide number 6. We had to write code for the LLM API access, the connections to tools and resources, the agent logic, all of that stuff. And then I said, look, this leads to a non-scalable mass of complexity you have to maintain when you want to grow your system, when you want to have multiple LLMs working in your system, when you want to be able to hook it up to resources and tools and prompts without having to rewrite redundant code and maintain complexity that doesn't scale very well, right? So we said that in the beginning. So what we're saying now is when we look at this scenario, we see that by standardizing and developing a protocol for connecting LLMs to resources, tools, and prompts, and whatever else you can connect an LLM to, MCP is trying to provide a way for us to say, look, let's make sure that everyone that builds an LLM API that provides you with some LLM API provider is going to allow you to hook it up to this protocol, because if you do, you're set in terms of scalability. You can scale really well because all the code you're going to have to maintain is just the connection to the model context protocol. And the model context protocol as a standard is going to standardize how these connections are going to work. And the architecture looks, in a very superficial sense, a little something like this. You have a host, which is the user-facing application, with subcomponents that handle a one-to-one connection to these servers, and the servers expose functionality to this client that the client can make requests for.